Hello, this is Deborah Karaoke from University of Texas, and in this module we are going to have a quick framework of what is discrete math for high school students. Discrete math is the branch of mathematics that deals with discrete objects. Discrete object set is one whose values are not continuous but rather distinct and separate, like people, letters, shapes, whole numbers, each of which has a unique predecessor and a unique successor. Discrete math is used by computer programmers to create algorithms to solve real-life problems. We therefore study discrete math because computing is usually more efficient with discrete values. In discrete math, there are three important tools that help us to describe and understand discrete math concept: sets, relations, and function. Let us begin by taking a closer look at sets. A set is an unordered collection of distinct objects. These objects are referred to as members or elements. The elements are separated by commas and enclosed within brackets. Sets form the basis of a lot of the operations we carry out in discrete math. We can do a lot of different things with sets, such as combine them to form union, separate them for intersection, or demonstrate the complement set, which is the set that contains all elements not found in the universal set. A set union combines different sets into one. Here's an example of P union Q. To further demonstrate this union, let us add members to P, 8, 1, 3, 5, and set Q. Let us add D, T, J, L. Pause the video for a second and see if you can guess what is the result of this union. The results of P union Q is 8, 1, 3, 5, P, D, J, L as displayed. The order does not matter. It's all the members that are found in both sets. The next section operation we are going to look at is the set intersection. The intersection of sets results has only the members that are common to both sets. Here is an example of P intersection Q. Once again, let us populate the sets with some members. Let us say that set P is made up of P, 2, 1, 5, 3, and set Q is made up of 7, 3, 6, 4. Pause the video and write down what you think will be the results of P intersection Q. The results of P intersection Q is the common numbers, which are 1 and 3. Here is how we display the answer in text. Even though it's 1 and 3 common in both sets, we only write it once. Now let us talk about the complement set. This U shaded orange represents the universal set, which is usually drawn as a rectangle. The universal set contains all the members under consideration. For example, as universal of people will be, a universal set of people would be the total number of people all over the world. Set P is a subset of set U, and its complement is denoted by P prime. Remember that the complement is the set that contains all the elements not found in the universal set, which is U minus P, which will give us the P complement. Now let us move on to relations. A relation is a correspondence between two sets called the domain set and the range set, such that to each element of the domain there is an assigned one or more elements of the range set. Let us look at an example. Here, the domain set called hair color, we have the following members: black hair, blonde hair, and red hair. In range set called people, we have the following members: Jones, Mary, Sam, Joe, and Tom. Relation mapping from the domain set to the range set is shown by the arrows as seen here. You will notice in this example, any given hair color in the domain set can be mapped to any number of people in the range set. A function, on the other hand, is a correspondence between two sets, the domain set and the range set, such that the element of the domain has one and only one mapping to the elements in the range. Here, the domain set contains a set of first names, and the range sets a set of last names. The function relation shown here shows a one-to-one mapping from the domain set first name to the range set last name set. Each first name is mapped to one and only one last name. This is a very important differentiation between functions and relations. In summary, we discussed how discrete math uses discrete objects. We then looked at the three tools that help us understand discrete math: sets, relations, and functions. With sets, we reviewed union, intersections, and complements. With relations and functions, we learned about the domain set and the range set. We saw that the crucial difference between them was the relationships can map one member of the domain set to many members of the range, while in the function, a member of the domain set has only one mapping to a member of the range set. Be sure to understand these terms before you move on.